Hello there, Khalid Amalawani here. An important thing that's available in Arduino that you should be aware of, and it is quite useful to know actually, because it turns out to be quite important in a lot of applications, are switches as well as Watchdog timer and the interrupt pin or the interrupt pins. The best way to talk about this, I guess, will be starting with the code right away. So let's get started. So first of all, let's talk a bit about each. So a switch is anything that provides a way to think of it is anything that results in an open circuit when inactive, and when it is active, it closes the circuit. So the switch that we're going to be using here is a tactile switch, which is mostly commonly known as a button. So that will be the one I'm holding right here. So the idea of a tactile switch is that, as I mentioned here, you just click a button, and when it is pressed down, it closes the circuit. When it is open or is up, it is an open circuit. And there's many other types of switches out there. There's a slide switch, which is a slightly different switch that has three output legs instead of two. Now, but most of the switches you'll see will be something like the tactile switch that I just showed you here. Now, if you look at a tactile switch, you'll notice that there is two on one side and two on the other. Now, let me just pull up a picture here just so we can see it better than the tiny screen on the side here. So if I just go on tactile switches, you'll see here that something like this or even like this, you'll see here that there is two legs on one side and two legs on the other. Okay? So the idea is here is that the leg on the same side are opposite of each other. What I mean by that is the circuit is completed by going from one leg here to the leg right beside it. But anything along the first and second leg are the same node. Okay? So that means that anything connected on the the leg I'm pointing at, anything connecting on the leg on the other leg right now opposite of it are on the same node. Okay? And anything on the same thing with the other leg and the one on the other side, they're on the same node. And to complete the circuit, you just need to connect it in a way where it goes from one leg here and it goes or goes at least from one side to the other side. It can go from this leg and go to the opposite corner, or go to this side and come to the near corner here, or maybe on the same side. So this is all important to understand in how your circuit design works. These are not four different inputs. They're only two different inputs on two sides. Okay, so if that makes sense, then we'll get right to the breadboard here. So what I'm going to do here is I connect my button right in the center. That is how it was designed to be made. So there's usually in any breadboard you have, there's usually a small gap, as you can see right here on the screen here. So there's usually a small gap here. The button goes right in between. So connect anything on the this side and on the left side, as long as it's on the same line, both of these now are connected. Okay, so this is how we connect our first button here. Now, in if we go back to the code here, it is important to always note how the connections or the pin out work. So one leg is connected to ground. Okay, so one of these legs here is connected to ground, which I have completed. And then the other one is connected to uh, an interrupt pin. In this case here, we're using interrupt pin 18. Okay, so it's just a simple circuit, just like this. So this one here is the interrupt pin connected to pin 18. This one is ground. Now, if we think about this, if we think about what we did here, if we click the button, that means we complete a circuit from the interrupt pin to the ground. Or in other words, we go from ground to the button, then we click on the button, it closes the circuit, and then it goes to the interrupt pin. So if the input, if the interrupt of if the pin is set up as input, if it's reading the signal, that means it's each time you press the button, it is zero. It's logic zero. It's ground, right? So that makes sense. But what if the button is up? Now you have an open circuit. What is actually happening there is that you don't know. You don't know what the voltage is. You don't know because it's not connected to VCC. You can't connect it to VCC. So what you actually do here is you initialize with a special variable called an input pull-up. That means when basically what the input pull-up is when the circuit is open, then assume it's logic one. Okay? So something very, very important to note is that input pull down does not exist. Okay? It's only input pull up. So if the O circuit is open, we set it as high. Okay, so that's how we do the first thing with the switch here, and that's how we make sure the switch works. If we just kept it as input, when the switch is open, basically you don't know where it is, so it could be open, it could be closed, you have no idea. So your code will not work properly. Second thing we can talk about here is the interrupt. So in this case here, what I meant by connecting it to 18 as the interrupt pin is first, let's talk about the syntax for an interrupt. So if you're attaching an interrupt, or in other words, declaring an interrupt, what you do here is the attached interrupt is the syntax you're going to use, and then you have here an interrupt, okay, and that refers to the signal that would trigger the interrupt. Okay, and then you have an ISR, which we'll talk to in a second, and then a mode. Okay, so the interrupt, the most popular types of interrupt, um, or at least the ones available on Arduino, are pin interrupts. Okay, the one available on Arduino pin interrupts. So this means that if the pin that is declared as the interrupt receives a high or depending on the mode receives a signal that correlates with the mode, that means that it will trigger the interrupt. Okay? But something important to note is that the interrupt pins cannot go anywhere. In the Arduino Uno, you only have pin 2 and 3 that you could use as interrupts. In the Arduino Mega, you have 2 and 3 as well. And you also have 18, 19, 20, and 21. As a side note here, remember that pin 20 and 21 are usually used for the MPU. So if you are using an MPU or you could see later even the real-time clock uses it, then you only have basically 18 and 19 as interrupt pins. So you don't have too many interrupt pins, but they usually do. You don't need too many. An ISR is known as an interrupt service routine. What that means basically is a special type of function. Now there's a few rules to take in for that special type of function. First, the function should not take any parameters, so you can't have anything between the brackets. It must not return anything, so it's always void. It's always a void function. And something to know is only one ISR can run at a time. That means if there is an ISR running, nothing else will run. And that is important to note as we'll get to in just a few minutes here. Because there is more restriction, but we'll see it at the bottom of this code here. Last thing we're going to talk about the syntax here is the mode. So the mode is just saying that when should I activate the interrupt? That's when the Arduino is thinking. When should I activate the interrupt? Either it's low, so when the trigger pin is at logic 0, when it is changing, so at any change, so if it goes from low to high or high to low, when it's rising, so when it's going from 0 to 1, or when it's going from 1 to 0, when it's falling. In the Arduino Uno and the Arduino Mega, there is no high, but other Arduinos, you can use a high. But in this case here, for the Uno and the Mega, you cannot. In this case here, for the purpose of our code here, we're going to declare an interrupt in digital pin to interrupt. Now, this is an important function because digital pin to interrupt, the values are different than the actual pin values. If I remember correctly, pin 18 was a digital interrupt of 3, or was an interrupt value of 3. You don't need to memorize this. All you need to do is just call the function here, digital pin to interrupt, and put in your interrupt number from the list that we declared here, and then it will declare the interrupt, or it will change it to the interrupt value for you. And then here we call the function name. Notice that there's no bracket even though it's a function. So that's the thing about the ISR is you don't include the bracket when you call in the attached interrupt. So and the names of the function has to match. Okay, which makes sense. And then we declare here the mode. In this case here, I want to activate it when it's falling. And then I also declared a global variable, or in this, yes, I also declared a global variable here called an interrupt counter. Notice that it's a volatile interrupt counter. What volatile means or basically when you use it is when a variable is going to be used inside a interrupt in ISR, in interrupt service routine, then you need to make sure you declare it as volatile. Otherwise, it may not work. So in other words, each time you see volatile, that means it's a variable that is used inside an interrupt, and it's always global. Okay, which makes sense because usually you would be using it, you'll be incrementing it or doing something with it short inside the ISR, and it will be reused inside the void loop. So it's most of the time, if not all of the time, it's global. So that's the volatile here is important to understand it, and it's pretty simple. So each time you use a variable that you're going to use inside the interrupt service routine, you just need to declare it as a variable. And then so we declare it up here, we assign it in the setup as proper convention. Last thing we'll talk about here is the watchdog timer. So the watchdog timer is actually a very simple design, and it doesn't even take too much to code actually. So the idea of the watchdog timer here is is that you declare a timer, and then the minute you enable it, it starts counting. Okay, it starts counting for a set amount of time. The amounts of time you can use for a watchdog timer are all preset, so you can go from 15 milliseconds to even 8 seconds. What happens here is that it keeps counting. Okay, it keeps counting until it reaches the reset. When it reaches the reset, as the name implies, it resets it. Okay. So if you think about it, it's quite simple. So that means that if the code lags, okay, which I will force it to lag at some point, if the code here lags or maybe even goes to a function and stops there, what the watchdog timer will do is that it will launch a a uh, a, a reset function. So what does that mean? That it will cause the board to reset. In this case here, to show that that happens, I am printing this is a setup function, and you'll see when the watchdog timer resets it, I will not be pressing any button except the interrupt button. So I'm not going to press the reset button, and you'll see that it will reset by itself. That's what the watchdog timer does. So so you call the enabler here, it reaches the WDT reset. When it does reach that, it resets the counter of the watchdog to 0. And then at the bottom, you always have to whether it depends on what you're doing here, but usually either you can include the reset at the bottom or the top. It's not too big of a difference. But in this case here, because I will be disabling it, which you can do. You can disable the watchdog timer at any point. If you do that, then you should always re-enable it after, let's say you're doing something that you know is going to take more time. Okay? The proper convention is to actually increase the watchdog timer. But let's say that you can't. Let's say it's above 8 seconds. Then what you can do is disable it. And then after you're done your function or whatever you're doing that takes more than the time requested by the watchdog timer, then you have to re-enable it, which is similar to what I'm doing here. Now, a common practice is when you're disabling it, you should reset it. Because if you disabled it at the maybe like only 1 second or 1 millisecond left, it will sometimes trigger it and it will reset even though you disabled it. So it's just a good practice to reset it right after you disable it. Not necessary, but it is a good practice. Aside from that, there's two other functions that you should be aware of is no interrupts and interrupts. If you're doing something that is time sensitive, that means that it cannot, no interrupt should happen while you're doing it. So what you should do here is call no interrupt. That means that if any interrupt triggers, it will not go to the ISR. It will just stay here. And then after you're done, you always need to remember to re-enable interrupts by calling the interrupt function. So there's nothing going on inside between these two functions here. So it will not be seen in the code. But theoretically speaking, if you do somehow not press the button and trigger the interrupt between here, it will not proceed. However, if there is a trigger of the interrupt, what happens? It's not ignored. It's kept till the interrupt function is returned, is re-enabled. So if the interrupt function is re-enabled, what it does, let's say you have multiple interrupts. What it will do is it will initiate it based on order. Okay, so if usually based on order of who called the interrupt first. So that means that if you have, let's say, interrupt of a button, interrupt of a MPU, DMP, for example, then let's say the button was first, so we'll call the after, and you have a no interrupt. So nothing will happen after you have after you call the interrupt function. It will go to the ISR for the button, and then it will go to the ISR for the DMP MPU, for example. Lastly, here is the ISR. Something to some do's and don'ts about ISR is that keep them as short as possible. You remember that when you're calling an interrupt, it's pretty much stopping the code until you complete your interrupt, right? So that means that nothing happens while it's in the interrupt except your code. So it is important to make sure that they're short as possible. And if you want to use a delay, use delay microseconds. Now, I put that with a grain of salt because it's not fully true because it only works up to 100 microseconds. Now, the idea is you cannot use at all millis or delay. Millis is just the function that allows it to count further. So that means the millis and delay are stopped. Why is that the case? Because they're both interrupts, actually. So how they're coded is the millis and delay are both worked through interrupts, which actually makes sense. But because they're both interrupts, then you cannot use it because recall what we said up here, you can only call one ISR at a time. And you can't call an ISR from within ISR, that's calling two ISRs. So it's not possible. So that means millis and delay are stopped. That means that if you do call an interrupt, it does not account for it in the millis function. That means that technically the Arduino has stopped. Each time you call an interrupt, it's like the Arduino has stopped. And that's how it works actually. So it stops the whole Arduino, it calls the interrupt, and then goes back to what it was doing. That's what it's doing, right? And then you can't use any serial commands as well. And you should avoid using for and while loops because it has to be as short as possible. So usually what interrupts are used for is for incrementation purposes or setting bools to true or false. So that's what they're used for. They're mostly used for volatile, volatile global variables that will be analyzed in the loop, which is exactly what we're doing here. So we have an interrupt counter that is declared globally, if you remember. And then each time you press the button, it will add it by one. So as long as the counter is less than one, it will disable the watchdog timer and keep going and re-enable at the end. Now, the minute the counter is above 3 or equal to 3, then the watchdog time, then it will not disable it. That means the delay 100 microseconds is bigger than the 60 microseconds. And as such, because the watchdog timer was not reset in the appropriate 60 seconds time, it will reset. Now, if I launch this code to board here, to the Mega, and it's done uploading and we open the serial communication here, what it is going to do is, first of all, let's set the proper baud rate. So we set the baud rate here to 9600. So let's do that. So as you can see here, it says here, this is the setup function. It's slow because I did add a delay of 100 microseconds, if you recall. And then we press the button once. It is now a 1. We press the button a second time. It is now a 2. We press the button a third time. And you notice here that it reset. So that's what the watchdog timer does. So if I do that again, it will reset always at 3. So that's how the watchdog timer as well as the button works. We see here that if I press the button, it clearly shows it. I did press the button twice here, but it clearly shows it uh, as a high input. So the input pull up does work. And yeah, so that's exactly how you would code this here. Something else to know about buttons is that they usually have a slight, as you're pressing the button, there's usually a slight error or noise. You can account for it and it's known as button debouncing. I will not walk through it, but it is something worth mentioning and something worth looking into if you will be implementing buttons, especially if the buttons are for sensitive input. That means if I don't press the button fully or it doesn't do a proper connection, you could actually read it as more than one input, and then I could try and force that. Um, it's not easy to do by hand, but it does happen. So if you press it slightly, it will debounce or it will bounce, and there is functions to debounce that, just making sure that never happens. So that is it for switches, interrupts, and the watchdog timer. They're quite useful, quite important to know, and they will apply for the MPU 6050, especially the interrupt. And the watchdog timer is just a very important function that you should include in all of your codes starting now, actually. So I hope this was useful to you, and see you in the next video.